Hey, look at your goofies in jail. I mean, why the long face when you got a long neck, boy?
Whenever you look at them, how are you actually supposed to read derivatives? I mean, it's understandable that they're the instantaneous rate of changes, but how do you, actually read them? Well, today, we're basically going to do some AP Calc practice by interpreting these derivatives with data tables. For our example question, let's use a scenario where water is simply flowing into a tank over a 16-hour period. There are values of hours and gallons here, and the function Wt is modeled to be differentiable. From here, we're going to start off with the first question. To find the approximation of W10, we can simply use the rate of change to get a good approximation. From following the formula of change in y over change in x, we can have an approximation that our derivative at 10 hours is going to be around 9 gallons per hour. And also, remember, whenever you're doing these questions, remember to put the units on, just to make sure you don't lose any points. Finally, we move on to the second and last question. Now this one is weird, so keep in mind. Imagine we have another function of jt and ht. To find the derivative for ht, we gotta use the product rule here, as we're simply multiplying different polynomials. Setting up our equation to be like this, it makes me wonder, how do we exactly get an approximate for the derivative of wt at 4? Well, just like the first question, we're just gonna approximate this and get an answer of around 8.875. From here, we can plug in the numbers once all the derivatives are set in place. And as a result, our function of f of 4 is in terms of the derivative will give us an answer of around 4,895.25 gallons per hour. Now, this is highly unrealistic, and you probably won't see this type of question on the FAQ. I am simply just trying to help you remember the essential rules when it comes to calculus. So, try to remember your product, quotient, and power rule.